All right, so lesson 1.4. I can subtract integers. Now, I'm not going to teach you how to subtract integers. I'm not. I'm actually going to teach you to take the subtraction problems, turn them into addition problems, and then follow the addition rules. Because addition already have these rules spelled out for us. We know that if the signs are the same, we're going to add. We know that if signs are different, we're going to subtract. So let's keep those rules because we were already assessed on them and everybody was either highly proficient or proficient. So we're going to take our subtraction problems and we're going to turn those into addition problems. And this is how we're going to do it. So the first thing that we're going to do when we're given a subtraction problem is we are going to change the subtraction sign to an addition sign. Now, do you guys know what we call that? A negative and a positive, a subtraction problem and an addition problem. It starts with an I. Dorian. Not integers. I think I actually heard somebody say it over here. Maybe not. Dennis? Intervals? No. Not an inequality. Inverse. Have you heard of the word inverse? Yeah. Do you know what inverse means? Yes. What does it mean?
It means changing it to the opposite.
Opposite. Very good. It means opposite. Now, after we apply the inverse to the subtraction sign, which is an addition sign, then we have to change the sign of the next integer. So we're going to change the subtraction sign into an addition sign. And because we did that, now we have to change the sign of the next integer. So if the next integer was a positive, we're going to change that into a negative, and vice versa. So let's take a look at 15 minus 23. The first number, Joel, is in cement. The first number is super glued, duct taped, in quicksand. You can't get it out. It's stuck. There's nothing you can do with it. And that's always the case. So because the first number is always stuck in cement, we can't change it. We just have to keep it the same. It's permanent. The first number is permanent. Now you'll notice that the sign is a subtraction sign. So what we're going to do is take the inverse. And the inverse of a subtraction sign is an addition sign. Now because we took the inverse of the subtraction sign, now we are required to take the inverse of the next number. This number is a 23. What's the inverse of 23? Reagan. Now that I have an addition problem, now I can follow the rules of addition that many of us mastered. Evelyn, what do the rules state when the signs are different? What should we do? And then how do I know if my answer is going to be positive or negative? Right, which number has the most negatives or positive? So do we have more positives or do we have more negatives, Evelyn? So then our answer is going to be -8. Now, I had kids in 4th and 5th hour say, well, that's not how I do it. Mr. Meeks, I do it this way. And I just changed that to an addition sign, changed that to a negative sign, and I got -8. And I'm like, well, that's great. I mean, if that's how you do it, then that's how you do it. Remember, I told you the other day, I don't care how you solve the problem. As long as you solve it correctly, you show your work and it makes sense, and you understand it. That's all I care about. Did you get the right answer? Did you solve it correctly? And does it make sense to you? All right, let's take a look at -15 minus 23. Well, this is a little bit different. A little bit different here. Remember that the first number is permanent. We can't touch it. Okay, it's off limits. But I'm going to change this subtraction sign into an addition sign. I'm going to change the 23 into a -23. And now I'm just going to follow the rules of addition. So are we going to add or subtract these? Dennis? Why? Yeah, they both have the same sign. So what's our answer going to be, Dennis? Yes, sir. Well, Mr. Meeks, that's not the way that I do it. I just do it this way, Mr. Meeks. I just change that to an addition sign, that to a negative. Signs are the same. I got -38. Okay? Well, Mr. Meeks, I don't even do it that way. I look at these numbers. I can see that the signs are the same, so I just add them because the signs are the same. Ha.
It's the same thing.
It's the same thing. It's the same thing. And I'm giving you these examples just because, I've been doing this for a long time, and these are the responses that students give me. Well, I'm not doing it this way. Is it okay if I do it? It's okay. It's fine. It's accepted. Oh my. 1, 2, 4. Smart. Do what? Supposedly. I do a pretty good job of faking it. Marlon does a good job faking it too. All right. Again, I'll just briefly show you how to do this. I mean, nothing's changing here. It's the same process for every single one of these problems. The very first number will always be permanent. It's not going to change ever. Because we are presented with a subtraction sign, let's change it to an addition sign since we know the rules for addition. But because we did the inverse of the subtraction sign, we need to take the inverse of the -23. which is a positive 23. And 15 and 23 give us 38. Ashton.
It's actually like what I do. When I get confused on this, I always do it your way. But also, I think to myself, well, when I see a positive subtracted by a negative, I connect the two negative signs to make a positive, so it looks like a big positive sign.
Yeah, you can do that. That's fine. Yeah. And I was just going to say that. Well, Mr. Meeks, I do it this way. I just see these two negatives, and I know that two negatives equal a positive. How about that?
I don't understand. They let you juice.
All right, now the last sort of example, the last situation, the last scenario would be negative 15 minus negative 23. Same exact process. Permanent. You're going to keep the first number the same. Inverse. Inverse. Follow the rules of addition. Rules state that since the signs are different, since the 15 is negative and that 23 is positive, signs are different, subtract, take the sign of the larger number. There's more positives than there are negatives. Do we, and in all serious question, are we going to change addition signs to subtraction signs? No. We're trying to change all of the subtraction signs to addition signs. Our end result, we are trying to get everything to be an addition problem. Addition is easier. Addition has rules to follow. Subtraction, it's kind of like in its own little universe, own little solar system. So we're trying to get all those into our solar system, into our universe, change everything to an addition problem. Jay?
But I don't do it that way.
I know.
How do you do it? You just ate.
Well, I just put, instead of negative 15 minus negative 23, I just change it to the positive.
Now, how about this? Now, this brings up a good question. So thank you, Jason, for bringing this up. If I was presented this problem on a homework assignment, practice, group work, whatever, could I rewrite it this way?
Yes. Yes, you could.
I could. And which property is this? Mako? It's not an association. Ashton?
Commutative?
Commutative. Notice that, just like what Spiegel said, both of these turn into a positive. So I could technically write this 23 minus 15. Is this 15 negative? Yes. Is this 15 negative? Yes. Is this 23 positive? Yes. Is this 23 positive? Yeah. Now, these problems are what I call bunny problems. These are all very easy, and we're not going to be doing too many of those. Our 7th grade problems so we're going to be doing 6 minus negative 14 plus 8 minus 13 minus negative 12. Or minus 2, sorry. Now again, like I've always said for the last 3 weeks here, you don't have to do this my way. I'm going to show you one way. I'm not saying it's the best way. I'm not saying it's the easiest way. But it is it's the neatest way. N-E-A-T. And when I say neat, I mean not like cool neat or awesome neat. I'm just saying that everything is going to be leveled. Everything's going to be in order. Everything's going to be sequential. Everything's going to look nice. Everything's going to present itself nicely. So let me show you one way to figure out the value of this expression. Like I said earlier, the first integer will always stay the same. Because we are presented with a subtraction sign, we are going to take that subtraction sign, apply the inverse to that, and turn that into an addition sign. Because I converted that into an addition sign, I have to take the inverse of the negative 14. I bring down the addition sign. I bring down the 8. From there, I'm going to find the inverse of the subtraction sign. I'm going to apply the inverse to the 13. I'm going to apply the inverse to the subtraction sign. And then I'm going to apply the inverse to the negative 2. And notice I have all addition problems. It's 6 plus 14 plus 8 plus negative 13 plus 2. What I'm going to do now to make my life easy is I'm going to add all of the positive numbers together. This is called the associative property. 6 plus 14 is 20 plus 8, 28 plus 2. And what's 30 plus negative 13, Brianna? On your own. Please find the value of that expression. Negative 15 plus 7 minus negative 8 plus 2 minus 6. Evan? No, thank you. Shh. All right, what did we get for our value, Lydia? -4. Dennis? 10. Dylan? 10. Guthrie? -16. Mason? -4. Kenzie? -16. Evan? -4. Little Sturge? -4. Ashton?
I got 26.
Oh boy. Chris? Huh? 8. Ellie? -4. Evelyn? 8. Reagan? Ari? 3. Gabby? Dorian? Michelle? Okay. Kind of all over the board. We're all over the place. All right, what do you guys think I should do with that -15? What should I change that plus sign into? What should I change the 7 into? What about the subtraction sign? What about the -8? What about the positive or plus? What about the 2? What about the minus? What about the 6? All right, now watch what I'm going to do here, guys. And eventually, as you get older and more clever with math, you'll start to find shortcuts. You'll start to actually look for shortcuts and easier ways to solve problems. Notice what I have here. I have a 7 and an 8. Why do I bring that up? Well, what's 7 plus 8? And what do I have here? What are those called? What's a -15 and a positive 15 called, Joel?
Neutral pair.
Neutral pair. So I don't even have to do anything with that. I'm not even thinking about the -15, the 7, and the 8 because they cancel each other out. They're neutral. What's 2 plus -6? And that's the answer.
I'd like to explain myself. When I run down the 15, I thought I accidentally put positive 15 instead of negative.
It's permanent. It's a permanent marker. You can't erase that. Stuck. All right, let's try one more. All right. Malachi, what did you get? 10. Uh-oh. We're in trouble. Matt? 12. Zach? Gosh darn it. Ryan? 12. Jadlin? Dorian? Brian? Brett? Benny? Chris? All right, let's see. What's the absolute value of negative 12? So I'm going to use the associative property here, thanks to Mako. 12 plus 3 is? 15 plus 11 is? And what's 26 plus negative 14? Say that again. And that's another good way to look at that. I'm glad you saw that. That's why I put this example up here. You can see 3 plus 3 is 6. 6 plus 8 is 14. 14 minus 14 is nothing. 12. Everything cancels out but that 12. So those little shortcuts there, that'll save you some time if you can identify them. Now, my question is, because I always get asked this, where does this appear in real life? Why do we have to learn this, Mr. Meeks? When am I ever going to use it? Hands down. I want you to write a scenario or a real world problem. Let's put that on there. Write a real world scenario for 24 minus 36. I would like a real world situation for 24 minus 36. Josh, what'd you get? You have what? Yes, please. Josh has $24 in his account. He then withdraws $36. That is a good scenario. Ari. All right, we're having a birthday party. A party pizza costs $36. You only have $24. How much more money do you need? Let's give another example without using money. I know all the hands go down. Joel.
It's about 249. It's about 250. You're in Mr. Meek's room. He asked you to write a scenario about it.
What?
When it's 2:50 in the afternoon and Mr. Meeks asks you to write a scenario about it.
What does that have to do with 24 minus 36?
Because we're going to have to write a scenario about it.
Am I being punked? Is there a video camera in here? It made no sense. Why don't we say Molly is 24 meters above sea level on a mountain and then climbs down 36 meters. What's up, Kat?
That didn't sell, but the money from selling the tattoos are all in here.
Awesome. Thank you so much. Can you guys give me a real life example of why a negative minus or a double negative equals a positive? When does that occur? Lydia? Ashton?
Because it's like saying, because a negative equals a positive. If, for example, say you're walking, but then you wouldn't say I went negative 4 feet. You would say I went 4 feet. Because, like, negative would equal a positive.
Well, when in real life will you get a negative? Because there are situations.
What if you have $4 in your bank account? You can say you have negative $4 and it's still equal $4.
It doesn't make Brett? Say that again? No? I couldn't hear you. Dylan?
So for Michigan, let's use vowel terms, we say one line. If you turn in $4 worth of cans, the store owes you $4, so you get positive 4, and they're losing, the store's losing.
That's actually a great example. Think about when you purchase a soda. Not only are you giving money, but then you have to return the can to get the money back. You're giving money to begin with. You have to pay an extra 10 cents. Then you have to return the can to get money back. So it's a double negative equals a positive. You guys know what a rocket is? Like a spaceship? I don't have a picture of a spaceship, but think of a rocket. What is pushing down on the rocket? Reagan. Gravity pushes down, and then what comes out of the rocket's boosters, Evan? Fuel is being burnt and pushed down. So gravity is pushing down, fire is going down, and then what happens to the rocket? Because 2 negatives equal a positive. All right, we're done for the day.